Okay, so the last couple of slides, we just wanted to really touch on what we have learned and where we think that the future directions, not just of this particular study, but of neuroinflammation and PD will go. And then, of course, some closing thoughts.
Great. So just to recap the landscape of neuroinflammation and PD, we have improved tools, patient cohorts, and data sets that strongly implicate a role for neuroinflammation in Parkinson's disease. Some examples of this are through GWAS studies. There are variations in antigen-presenting genes that confer a slightly increased risk for late-onset Parkinson's. Preclinical models of Parkinson's have an inflammatory component present that contributes to nigral neuron degeneration, and interfering in that process can alter pathology in these models. Epidemiological studies have shown that chronic NSAID regimens early in life can lower the risk for Parkinson's later in life. Mutations in LRRK2, which is a genetic risk factor for Parkinson's, have been linked to inflammation through multiple studies and mechanisms. There are still outstanding questions, such as what is the role of inflammation in the gut and how may that contribute to Parkinson's pathology? What's the impact of misfolded proteins on initiating inflammation? A hallmark of Parkinson's disease is misfolded aggregated alpha-synuclein. Is that possibly triggering this process? What is the role of neuroinflammation in other neurodegenerative diseases, and how can efforts be synergized between different foundations, different labs, different groups to kind of learn from each other and move the needle forward in multiple disease states? And also, what is the role of inflammation that should be considered in the development of disease-modifying treatments for Parkinson's? So can we develop treatments to target neuroinflammation in Parkinson's to reduce pathology? Can we develop imaging tracers and biofluid biomarkers for patient stratification, measures of disease progression, or maybe diagnosis? And can we develop improved assays and tools for PD biomarker discovery and screening that can help us with these efforts? And especially those last two are highlighted because those are really what our focus was in this effort.
And so really the last slide that we wanted to leave you with is this sort of snapshot into the biomarkers of neurodegeneration. So this is really not a comprehensive image, but it's just really meant to show you that there's so much research that has gone into trying to inform these circulating biomarkers in neurodegenerative diseases. And obviously the projects like the ones that we were lucky enough to participate in with Michael J. Fox are aiming to help advance that. We typically have more questions than we do answers, but it gives us a really exciting starting point to try and tackle some of these problems. And so with that, I want to thank all of the people on these slides who were involved. So first of all, to Nicole and the rest of the Michael J. Fox colleagues, again, this has been a labor of love for 2 years of lots of discussions about project design, project scoping, panel design, analyte, sample types. It's been a great collaborative effort, and I'm so appreciative. And to all of our collaborators within the Michael J. Fox Foundation and at AppCam, particularly Sandy, who manages the AppCam-Michael J. Fox relationship, and then, of course, all of the other assay development scientists who were involved in the panel and project design. And so thank you all for being here. And of course, if you have any questions, we're happy to help answer them here, or you can come visit us at our booth. Thank you. Are there any questions? Yes.
Can you look at correlation between the CSF and serum samples?
That's an excellent question. So the question was whether we looked at the correlation between CSF and serum samples. We did not. That's something that we can certainly go back and look at. Yeah. Because that, to your point, one of the questions that we asked is, do you see an enrichment in some of these biomarkers from either CSF into serum or vice versa in disease progression? Yeah. Yes.
So you've done a lot of work with protein and RNA. How about lipids? For example, how about prostaglandins? It's so well established and helps to evaporate in Parkinson's. And this field is so unexplored. And maybe we will get some better biomarkers. So I'm very interested in having these tools to analyze prostaglandin profiles.
Absolutely. So the question was whether, in addition to the genomic and proteomic biomarkers, we've also looked at lipids that are obviously implicated in PD. So at the moment, we don't have a way of looking at prostaglandins or other lipids on the Fireplex platform. However, within our portfolio at AppCam, we do have assays that look at that. And so one of the future directions that we are exploring is whether we can bring in other assay platforms to inform this, or if we can do some finagling of assay development to somehow look at lipids on the particles. So it's definitely part of the things that we'd like to investigate, certainly, yes. I think there was another question maybe in the back. Or I just answered it. Yes.
So I know that you've developed this for human studies, but there's so many amazing transgenic mouse models that can be evaluated.
Absolutely.
Are you planning to make a multiplex system that can evaluate differences in treated and untreated mice?
That's an excellent question as well. So the question was, all of the data that we took you through and all of the panel development was done for human samples and human analytes. And so the question was whether we plan to do the same for mouse samples. So actually the mouse 70-plex cytokine discovery panel just completed assay development last week. One of our assay development scientists is in the back. Actually, she was telling me about it yesterday. So that will be probably ready to go in about a month's time. And then we would be able to apply it to those studies, certainly. Yeah. Yes.
I have a question about your agenda.
Please. Yes, of course.
Because you talk about, I mean, the dynamic range is really impressive, and you showed that in the figure. But it says that it's relative to other platforms, but
So that's a good question. The question is related to something that's in the Fireplex literature, looking at the dynamic range of the assays. So what we did is the dynamic range, for example, in the standard curves that I showed you, is just the performance within our own assay. What we did is we looked at the published sensitivities and published dynamic ranges for other bead-based assays, comparing them to Fireplex. And so what you're looking at is a data sheet versus data sheet comparison, and essentially looking at the number of targets that we can either more sensitively detect or have a broader dynamic range in our portfolio versus on the other bead-based providers. And I can take you through more of that if you'd like. Yeah.
does the multiplexing increase the sensitivity for any individual one?
That's an excellent question. So the question was whether the multiplexing decreases the sensitivity. So as a part of the 70-plex panel development, that was one of the first questions that we asked, because we knew we were working with fairly dilute samples, or we needed them to be as sensitive as possible. So the assay development team actually started by building 8 smaller plex panels that they then tested the performance of and started to piece together in these modular entities. And one of the criteria that we had for panel development was that we not lose sensitivity of detection in 70-plex compared to like a 10-plex, because we could just simply run more panels if we needed to. And so based on the standard curve, what you see is that the limit of detection and lower limit of quantitation is almost identical between the 17-plex panel that we had and the 70-plex panel. So we don't really see a loss in performance there. Please.
So based on the results that you got, the results were like across those 695 or something, some of them were beyond the upper.
Yeah.
So based on that kind of first pass results, did you ever subdivide panels such as you then have your high dilution panel or your low?
Right. So the question is related to the analytes that for serum and CSF fell outside of the upper range of the standard curve, which honestly, I don't think many of us were expecting. Do we plan on rebuilding the panels and splitting them out? And absolutely yes. So one of the other panel development criteria that we employed is a 70-plex panel is only useful if you can do a single dilution and detect everything. And so the strict criteria we had was that everything had to be dilution matched, and these were all run at 1:4. What we knew, though, was that we'd run these studies and then we would have to dilution adjust. So the goal is to go back and split that panel out for the targets that fall outside the upper limit of quantitation, split them out and do higher sample dilutions. And for everything else that fell below the limit of quantitation, split those also out and then do lower dilutions for those. But the good news is that you can still start with one input and do the serial dilution, so you're still not going to use way more sample than you would. So yes, that's going to be in phase 2 of these studies. Any other questions? Awesome. Well, thank you all again for being here, and thank you, Nicole.